All right, so that's the system overview. It's pretty cool. I like it. I like the way that we designed it in that it could be used with the PS4 controller or the actual system. It allowed us to test this layer without having to have built this entire layer already as well. So I'm going to very briefly go over how this algorithm is supposed to work. Yeah. Okay. So basically, well, like I was saying earlier, we have this color group. We look for this collection of pixels, like pixels that are like this hue, and then we say, hey, that's where the drone is. And we look for the biggest group of these colors in the image. That's how we don't have to do any like really complicated tracking stuff. It's literally like, hey, where is the biggest group in our array of pixels? That's just like the image coming in from the camera. And we say, okay, that's where the drone is. I'm actually going to fully use the presentation for this because it's, well, designed to help communicate this information. So the first thing we do for our control algorithm is we find the biggest group of that color. So that becomes the red dot. And I know you saw it earlier, but like underneath this green dot is a red dot. And that's where we think the drone is right now. And that's good and all, and you can actually see that data captured over here as well. That's good and all, but what if the drone moves like super fast or something like that? Then it like sort of gets lost. And that's not cool. We completely lose where the drone is. We send some commands to get it back where it is. So hypothetically, the drone is here. It's not very far away, but then it appears over here because that color group was largest over here. That's a serious problem. So we take a weighted average in case we lose it. Which is both good and bad. In this case, it was bad because the drone was sort of way ahead of where that weighted average was. So we're essentially taking too many samples, and it meant that like our control algorithm would think the drone was like further away than it is, and give commands that were like wrong based on that. Yeah, so you can see too many samples cause lag, and too few samples would also make it so that we couldn't calculate velocity. And this velocity thing is actually really important in the way that we chose to control the drone. Yeah, so you can see this is one of those trash situations where the drone is believed to be across the room, and it really is like stationary right there. So, anyway, we cleaned up that data, we take that weighted average, and we found a balance that allows us to calculate that velocity without having the drone's legitimate position be misrepresented by like a value that is holding too much historical data. So for every single frame that we get in, we take the difference from where we believe the drone to be to our target, which is this blue dot right here. So this is where we believe the drone to be, and our target is here. We take that difference, and then we generate these commands. And the whole algorithm outputs to that Mamba format string. So it's like 5 parameters that we send to the Raspberry Pi over the network, and that's it. All this vision stuff, it all comes together to generate that string, but doing so automatically, and doing so in a way that gets us really close to our target, even closer than we could have gotten by piloting the drone with the PS4 controller. And part of that is that we're not professional pilots, but the other part is that it's actually quite difficult to have this like virtual place in the room that you're trying to get to, and looking at it through the screen is a terrible idea. It's just your whole sense of depth and everything is very wrong. But yeah, so after we send those commands, the Raspberry Pi receives those values and applies them if they got there in time. So again, that whole timing thing. If it gets there too late, we don't care about it anymore. That's not relevant information. We move on, and we use the next value that comes in. And this runs on a loop. So that whole control algorithm sends a command, and then by sending that command that affects where the drone is in real life, we start at the top of that control system again, and you can see that we're receiving where the drone is. We're doing all that data cleaning, and we pass it all the way through. We generate our mount by format string, and we send that out again. And that just runs and runs and runs until it gets to the target, where it actually continues to run to maintain the target, because this is like a moving system. It's not like we're driving a car. Okay, it's not like we're driving an RC car, and we need to get to one point of the room, and once we're there, we're there. It is, we are trying to stay afloat in this sort of fluid dynamic space with this force gravity acting upon us all the time as well. Cool. And yeah, so like I was just saying, it just keeps going up and up and up that list, sending commands to the drone, us getting data on where the drone is, and that going back through our system and sending out commands that update the position of the drone. Cool. Thanks for checking out this video. Check out the other videos in this series. And if you've liked this, you can like it, and if you want to subscribe, you can subscribe. Peace.